Hello there, it's Mr. Rops, and today we're going to talk about exponential modeling again, and we're specifically going to talk about making horizontal asymptotes and what they mean. And so the context of today's video is about music video, Sorry, from Justin Bieber. And in 2015, when Justin Bieber released his hit, Sorry, it's a daily maximum YouTube views of 11 million views per day. This day here in January, it hit 11 million views in January 2016. The data set shows the months since January 2016 as T. So these are the months since January 2016. And S-axis here are the number of daily views in the millions. So this is 11 million views and so on. So this is January 2016, 11 million views and so on. This is what the data set says. Okay, so this is 3 million views, or 3 months after January 2016, 5.5 million views. So looking at the graph, determine a reasonable horizontal asymptote. When you look at the graph here, it does look like it's tapering off. And I'm going to switch windows here. And so it looks like it's tapering off. And we have to find what we think is the horizontal asymptote, which is a line that goes across this way. Let's see if I can make it a little bit bigger and bolder. Okay, so here's our horizontal asymptote. And so if I come over to I can change this value up and down, anything. And so I'm trying to choose a value where I believe the line, this data set, will never go below. That's what the horizontal asymptote is. And so I could go as far as to say that this is 0. But I can tell from the data that it's 0 is not appropriate. I think it's going to be something higher than that. And so when I start to play with it, and granted I've set this up already, I feel like it's 2.4 is a little bit too high. I feel like it's going to be right around about 2.2. And granted, there's a couple days that's gone below, but that kind of feels like the bottom edge. And so there are a lot of correct values you could choose. A lot of correct values. There's a lot of incorrect values too, but this is not a one answer is the right answer. There's lots of different possibilities. So I'm going to choose 2.2. And so what value am I looking to reasonable horizontal asymptote is going to be 2.2 million. And so what I'm saying is that the horizontal asymptote, is it reasonable? Yes. And I'm saying that the YouTube daily views will never go below 2.2 million. Now, is this reasonable? Well, I don't think it's unreasonable to consider this. And you can even say this is going to be true up until a certain point. But I do think this hit, Sorry, was a video and a single that everyone around the world has recognized or knows. It was very popular. I would say even your grandmother would recognize the song. She may not be able to name it or know the artist, but it will go, oh, I know that tune, and so on. Okay, so we are going to say 2.2. And now I also know that this value at the top, the y-intercept of 11, or the s-intercept of 11, it consists of the asymptote, which we call C, plus A, and that makes the y-intercept. And so my y-intercept I know is 11, and if my asymptote C is 2.2, then my A value is going to be 8.8. And so what I can say is I know that if this is my model, let me try that again. My model, I know I'm going to talk about S at T, which is the number of Sorry views, S for Sorry, T is time, follows this pattern here, T plus C. And I know that C I've just claimed to be 2.2 because that feels good. B I don't know. If I use the 0 value for T, A I don't know yet, and I know that this has to be 11. And so if I do some algebra on here, I subtract the 2.2 which gives me 8.8 is equal to A times B to the 0 is 1. And so that means I know that A is equal to 8.8 is my A value. And the y-intercept up here, which has been cut off, is 11. And it's really the S of t intercept, the maximum number of YouTube daily views of the song Sorry. Okay, and so now we have our A value is 8.8 and our C value is 2.2. In doing that, choosing your horizontal asymptote appropriately and then calculating your A value works for either method 1 or method 2. And so now I have this data set here. I can use the 0.27 to find an estimate for B. And so I go over here. I know 7 is my S of t is equal to 8.8 B to the power of 2 plus 2.2. Okay, I subtract my 2.2. If I do that, I go 7 minus 2.2, which gives me 4.8. This is 4.8 is equal to 8.8 B squared. Divide by 8.8, divide by 8.8. And I know that B squared is the 4.8 over 8.8. And when I do that calculation, this says it should be 73.85. Okay? And so if I consider doing it with a spreadsheet, here's the calculation here. And if I look here carefully, so what I've done is I've taken 2.2 and I subtracted 2.2 from all of these S values. And I got 4.8, and I went 4.8 divided by 8.8. That's going to be constant each time, divided by the square root of this value here, is what I know it's going to be. And I calculated all the values. And so you take a quick shot so you can see what the values are supposed to be. But these are the values you should get because I'm not going to do them for you this time. Go ahead and finish it off and then get your average, and then you'll have your model for this one. Okay, I'll let you calculate the model for this method. That will be due for yourself to do. And then we consider the second method. Again, A and C are both done the same way. But now that we've gotten C and we have our table, we're going to subtract C from all of these values. So we're going to work with this column here and so on. And if I look on the menu here, this is subtracting C, all these values here. And so now 2 months after 2016, 8.8 was multiplied by the B factor twice. So to go from 11 to 7, or rather, I should not say 11 to 7, but to go from 8.8 to 4.8, I had to multiply B 2 times. So I know that 8.8 times B squared is equal to 4.8. And so then I can solve for B squared, and then I can get B again to be the same value. For the first value is often the same. When I go from 4.8 to whatever this value is, went from 2 to 3, that's multiplied by 1B. So 4.8 times B will give whatever this value here is in the square. And so I want to finish this table off. And when you're done, if you've done it similarly, here's the table you should get. You should get 7598. Here are all the values. And that will give you your model. Once you have your model, you choose which one of the two models is the better of the models. Look at the picture and see what you see. Okay? Look at the diagram, see which model, in your opinion, fits the best. Okay, and then we have the key features. Well, when we start to think about what the key features are, well, I know S of t is the daily hits in millions of views. The x-axis, which is really not the x-axis, but it's the t-axis, and it's time in months since the maximum number of views. And the y-axis is not the y-axis, it's the s-axis, it's the daily number of views in millions of views of Sorry. Similarly, our B value, if you choose to get a B value, let me find the B value. Let's say the B value is 7598. If this B value is 0.7598. That means if I subtract it from 1, 1 minus 0.7598, 2402. So when I subtract it from 1, I get 2402. That means there is a 24% decrease in daily views. Okay, and so this is an important number to get. It is quite important to recognize that it's always subtracted from 1, and this is 24.02% decrease in daily views. That's why the graph is going downwards. What's the t-intercept mean? Well, the t-intercept, where is it across the t-axis? Well, in this case, it does not exist. It's impossible to cross that axis because we have an asymptote that is at 2.2 million views. The horizontal asymptote, well, what's that talking about? Well, the horizontal asymptote is the amount of daily views that will never go below. In this case, is 2.2 million daily views. And finally, discuss the limitations in the domain. Well, theoretically, the domain t can be any real number, but practically that doesn't make any sense. The t-value is defined as time in months after the maximum daily views. So t should be a positive, as negative is irrelevant. It makes no sense. So if I have a maximum 11 million, if I go back in time -1 month, I'm not going to have a larger number. So that doesn't make sense to have negative values. Theoretically, though, t can be any positive number, but again, practically makes no sense. This song, Sorry, was a world phenomenon. Your grandmother may not know the name of the song, but will probably recognize it if she heard it. So saying 1 million views per day when thinking about the automatic playlist on YouTube is not an unrealistic or unreasonable, especially for a few years after it was released. So I would say the practical domain is reasonable to consider up until January 2019. So then the domain should be between 0 and 36 months, so 3 years afterwards. But as mathematicians, we know that our models are not perfect, but they try to reasonably describe what's going on. Now, there are lots of different domains that are reasonable to choose. There are lots of wrong ones, but there's lots, if you can justify why you've chosen it, that are reasonable to consider. Finally, these last 3 questions, I'm going to leave them for you to answer on your sheet because these ones are within the realm of you being able to do it.